The maturity method concept has been around since the 1950s, but it has been more recently that Nebraska fully implemented its use. The Nebraska Department of Roads has used this method for acceptance testing since 2001. The maturity method is a simple technique for predicting concrete strength in place of conventional cylinders based on the measurement of time and temperature history. Prior to construction, a relationship is established between mixed strength and time temperature history to estimate reliable, real-time, in situ strength. This maturity method monitoring training video will cover the basic principles, terminology, and field applications of the maturity method, and the equipment and techniques needed to perform the maturity testing. The training follows ASTM C1074 standard practice for estimating concrete strength by the maturity method. Keep in mind that this training does not address all issues that may develop during construction. The contractor may request the use of the maturity method on a project basis. The request shall be made in writing to the Materials and Research Engineer. The Materials and Research Division, or a certified consultant, will establish the relationship between mixed strength and time temperature history to estimate real-time in situ strength. This relationship is represented by generating a curve, which is then submitted to the project engineer and field inspectors. The inspectors will use the minimum target time temperature factor developed by the maturity curve for structure form removal, opening, and acceptance design compressive strength. The target time temperature factor value shown represents an estimated opening concrete strength of 3,000 psi for this concrete mix design. This will be of significant use to the project field inspector during the monitoring of the daily concrete placement. The maturity method can be conducted using minimum equipment. Some of the required tools and equipment needed to perform the maturity monitoring are shown. A digital thermometer, maturity meter, Type T thermocouple wire with Type T mini connectors, and tools such as tape, a screwdriver, wire snips, paint, ribbons, a stake and hammer. The preparation of the thermocouple wire is extremely important for successfully acquiring temperature data. This is a correctly prepared mini connector and wire. The wires are attached to the correct screws, nickel to nickel and copper to copper. When the wires are connected to the incorrect screws, it will cause an inaccurate temperature reading. This shows an incorrect wire assembly due to the wires being too long, causing the wires to touch. This will also give an inaccurate temperature reading. The temperature sensing wire end requires proper preparation. Strip off approximately 1 inch of the wire insulation. Next, twist the copper and nickel wires together to form a closed circuit. The last step is to snip the wire off so there is approximately ½ an inch of wire exposed. The most common failure occurs at this point. One of the wires may break during the twisting of the wire. A prepared thermocouple wire length will depend on the application. A thermocouple wire may be prepared longer than would normally be needed for a one-time use to allow for multiple uses of the wire. 2 maturity installation applications will be presented in this training. One application will cover pavement repairs and miscellaneous placements, and the second application will cover mainline paving operations and structures. The first step is to determine where the thermocouple wires and connectors will be placed. It is recommended that you place your wires at the beginning of the day's placement. It is suggested to set up as far away from traffic and construction equipment as possible. It is also recommended to install 2 thermocouple wires to monitor the concrete placement. Both wires may be installed at the same location at the beginning of the day's placement. Another option is to place 1 wire at the beginning and 1 at the end of the day's placement. 2 thermocouple wires are always recommended in case of wire malfunction. The most common installation method is by attaching the thermocouple wires by tying or taping them to an existing tie bar or dowel bar in the removal area. Run the wires onto the adjacent slab of the removal area. Test the wires for conductivity by taking a temperature reading with a monitoring device. Once the wires have been tested, it is recommended to take measures to protect the wires and connectors from being disturbed. This may be accomplished in several ways, not limited to the examples shown here. You can mark your locations with paint. You can attach ribbons to the wires. You may use a cone to protect your wires. Or you may also place your wires in a cylinder mold. To install thermocouple wires where steel bars do not exist, you should place a stake or rod at a minimum of 1 foot from the edge of the existing slab and at approximately mid-depth for the concrete slab placement. Next, attach the thermocouple wires by taping them to the stake or rod. Protect the wires when possible by burying them in the subgrade and run the remaining wire onto the adjacent slab. Test your wire connectors for conductivity and take the necessary steps to protect the wire from being disturbed, as shown previously. Another application where the maturity method is utilized is for mainline slip-form paving operations. Thermocouple wires can be used at any point along the pavement slab. A minimum of 2 wires shall be used in each day's placement. It has been found that concrete does not gain strength at the same rate. Therefore, it is recommended installing thermocouple wires at the beginning and at the end of the day's placement, and optionally installing one in the middle of the day's placement. After the location has been determined, mark the area. Next, by using a heavy gauge wire, penetrate the side of the slab to a minimum of 6 inches at approximately mid-depth. One method to install the wire into the slab is by placing the wire over the tip of the heavy gauge wire. Next, proceed to insert the thermocouple wire into the existing location. Then, utilizing fresh concrete, fill the void around the wire. And proceed in checking the conductivity of the wire by taking a temperature reading with a monitoring device. Make sure to record the date and the time that the initial temperature was taken at each location. After the data is collected, it is recommended that measures be taken to protect the wires. The setup and monitoring procedures for structures are similar to those for slip-form paving operations. It is recommended using a minimum of 2 thermocouple wires placed in the structure, with a minimum concrete coverage of 2½ inches. The placement of the wires into the structure is at the discretion of the project engineer. Test the wires for conductivity by taking a temperature reading with a monitoring device. Once the wires are tested, it is recommended to take measures to protect the wires and connectors from being disturbed. The time temperature factor for concrete maturity method can be performed using 2 procedures: a concrete maturity meter or a digital thermometer. When using a concrete maturity meter, the time temperature factor value can be read from the meter in real time. The alternative method is taking the temperature readings using a digital thermometer. These temperature readings shall be taken in degrees Celsius and are used in calculating the time temperature factor value. The Nurse-Saul equation is used by NDOT for calculating the time temperature factor value by hand. The time temperature factor at age which the calculation is performed. The average temperature using the initial temperature and the elapsed time temperature reading. The datum temperature, -10 degrees Celsius. This is the temperature at which concrete is no longer gaining strength. The time interval, which is represented in hours. This is an example problem calculating the time temperature factor value using the Nurse-Saul equation. Inspectors take an initial temperature reading of 19.7 degrees Celsius. The temperature readings may be rounded to the nearest whole number, 20 degrees Celsius. The initial temperature reading shall be taken within 10 minutes after the concrete has been placed. In this example, another temperature reading is taken 3 hours later, reading 50 degrees Celsius. Next, the average temperature is calculated using the initial temperature and the temperature reading taken at 3 hours. The average temperature calculated is 35 degrees Celsius, and the delta T, the time interval, will be 3 hours. Following the Nurse-Salt equation, you must subtract the datum temperature from the average temperature of 35 degrees Celsius. The datum temperature used in this region of the country is negative 10 degrees Celsius. Always remember, subtracting a negative number is the same as adding a positive number. The result is 45 degrees Celsius, which is then multiplied by the time interval of 3 hours to give a time temperature factor value of 135 Celsius per hour. This time temperature factor value calculated must meet or exceed the target time temperature factor value from the maturity curve which was generated for this specific mix design. An Excel spreadsheet may be used to calculate the time temperature factor value. This spreadsheet is used primarily for paving and structure applications, but may also be used for pavement repairs. Enter the data into the highlighted data field. The spreadsheet will calculate the time temperature factor at age and the sum time temperature factor for each individual date of data entry, providing the most current time temperature factor value for the last date of data entry. Contact the PCC laboratory for questions about testing procedures. Data acquired for determining the opening and acceptance of concrete placements shall be recorded into Site Manager. The Department of Roads requires that field personnel will be responsible for maintaining electronic documentation in the Site Manager application. There are 2 templates for entering the acquired data in Site Manager. Choose the correct template for the concrete application. This template in Site Manager represents the Mainline Pavement Structure Maturity Report. The intended use is to determine when to open a section of pavement or form removal or loading of a structure. Currently, NDOT does not use the maturity method for acceptance of concrete for mainline pavement and structures. This template represents the Pavement Repair Maturity Summary Report and is used for the determination of opening and acceptance of concrete pavement repairs. The Nebraska Department of Roads uses the maturity method as an option to test cylinders for the acceptance of concrete pavement repairs. This concludes the maturity method field monitoring training. There will now be a short quiz covering what you have learned.